Hi, it's Jason Gorman from Codemanship with the fourth in our video series on test-driven development in C#. If you've missed the first three videos, I highly recommend watching those first. There'll be a link to the whole series in the description below. In this video, we're going to be talking about duplicate code, and we're going to be exploring three things around this topic. One is the relationship between code duplication and abstractions in our code. And then we'll be talking about the rule of three. When do we remove duplication? And we're looking really here not to jump in too early and not to leave it too late. And then finally, we're going to be talking a little bit about when we should leave duplication in our code. So we don't always remove the duplication. Sometimes it's better to leave it there. So three things to look at, and we're going to be exploring these using an exercise that you can find online. There'll be a link to that in the description below, called the Mars Rover Kata, K-A-T-A. This is just a TDD exercise that, as it happens, involves quite a lot of duplicate code. So this will be a nice one to demonstrate with. Before I do this, just point out I'm going to be writing my unit tests within Unit 3. You'll see in my NuGet packages below that's installed. And if you're working in Visual Studio, there's an adapter for NUnit 3 that you can use to run your tests. And also, if you're using VS Code, I believe there's a plugin for that too. So we should be ready to go. But before I do anything else, there's something that you may have noticed if you've watched the previous videos has been getting in my way a little bit. We talk in the second video about writing the test assertion first and working backwards. And quite often I'm using my IDE to generate code, to generate declarations of classes and of structures and of methods and properties. And by default, Rider and Visual Studio are set up to generate code that throws a not implemented exception to remind us that we haven't written the code yet. Now we're writing tests that won't pass unless we've written the code to make those tests pass. We don't need this. We don't need to throw these not implemented exceptions. And it really, frankly, it just gets in the way. So I'm just going to quickly switch that off. If I go to my settings for this project, we look under the editor settings, we've got a tab there called member generation. And you'll see that I've switched it off already, in fact. By default, it's set up to throw this not implemented exception when we generate member bodies. I'm saying don't do that, please. If there's a return value, please generate a default return value, like a default string or a default number or null. Okay, so we'll save those. So it'll stop generating that now, because that was really starting to annoy me in those previous examples. So the Mars Rover Kata, I'm not going to do the whole thing. I'm just going to focus on one part of it to illustrate. The idea is that we can drop a Mars rover onto an idealized grid that represents the surface of Mars that has X, Y coordinates, and the Mars rover is facing in a certain direction, north, east, south, or west. And we can turn the rover right. So, for example, if it's facing north and we turn it right, it will end up facing east. And we can turn the rover to the left. So if it's facing north and we turn left, we end up facing west, for example. And we issue sequences of instructions as individual characters, like R for right, L for left, and so on and so forth. So that's kind of the basic idea. There's more to it than that. If you read the description of the exercise that I'll put a link to below, then you'll see there's quite a lot more to it. It's quite a fun one to do. But I'm just going to focus on turning left and right because that's going to be enough to demonstrate what we're talking about here. So it's test-driven development. So we're going to start by writing an NUnit test. There we go. And this first test is going to be, for the simplest example I can think of, for turning right. So it turns right from, let's say, north to east. There you go, a nice descriptive test name. I'm going to write my test assertion first and work backwards to the setup, so we end up with exactly the right setup we need. So we're saying it should end up facing east, and our rover, let's imagine such a thing exists. That's the way it should be facing. So we're imagining things that don't exist yet and working our way back to them. That's going to be of a new class. So let's generate that class. So notice how I'm using the IDE to work backwards. And let's create a new instance of that. To begin with is facing north, N for north. Let's generate our constructor, which will now not throw an exception, as you'll see. So it doesn't throw an exception. Great. And that's the way that it's facing to begin with. Okay, let's just quickly generate a get only property. That'll be fine for now. And let's tell the rover to go R for right. Go to the right, please. We can work backwards, generate that method. And that's our instructions. So my design for the rover is basically we give it a sequence of instructions, which could just be a single character like R for right or L for left. And now when we run this test, it should fail because at the moment it's not facing in any direction. Excellent. Let's see why you're failing. Yeah, it was expecting east, but it's null. Okay, now to pass this test, let's triangulate. So I think this one is non-trivial. It's going to be non-trivial. So I'm going to take little baby steps. And I'm just going to do the simplest thing I can think of for now. So let's just return east, and that should work. Okay. It's probably going to tell me that I can do, oh, yeah, we can do that. It's C#, so nice and easy. Simplest thing. Okay, there we go. That's one example. Let's do another example. It would make sense to go sort of around compass, if you like. So we've gone from north to east. Let's go from east to south, turning right. No, east to south. So assert first, work backwards. So we should end up facing south. There's our rover. Generate a local variable for that. See how the tool, once it's correctly configured, helps me to work backwards. Let's make it face east to begin with. And let's tell it to go to the right. Okay, let's run our tests again. And now we should have one failing test because it's facing east. We want it to face south. Okay, let's just take a look. Yep, expected south, but was east. Okay, what would be a simple thing we could do to pass this test? Well, I guess at this point we do need to know. So let's, oops. If you would be so kind. I don't know why you're doing that. So there's our get. This time we're going to need a private set. And we're going to assign our direction here. And now our go method is going to have to do a little bit of work here. So if we're facing north, then we're going to tell it to face east. And then we'll just return. Otherwise, face south, nice and simple and flat. Oops. Bouncing all over the place with my editor today. So that should work. Okay. What are you complaining about? You should be facing should be haha. I keep forgetting that I'm working in a statically typed language. Okay, right. Let's just run the test again. And I think it would make sense now to put Rover in its own. So let's move it to its own file. That makes perfect sense for now. And back to our tests. Okay, now at this point we can see these two tests are very, very similar. And so we've got some duplication in our test code. And what might happen if we carry on adding more and more tests is we're going to end up with lots of tests that are kind of the same, very, very similar, tiny differences. So we end up with a lot more test code that we have to maintain. And it's very, very important to remove duplication if you think you're going to end up with lots and lots and lots of it, because basically it just means there's going to be more and more code to support. You're going to have to make the same changes in multiple places. So from a maintenance point of view, duplication can cost us. But at this point, I've only got two examples. And this is where I want to talk a little bit about the rule of three. So the danger when we refactor our code to remove duplication is that we end up introducing the wrong abstraction if we refactor too early, before we've kind of spotted the pattern. So to sort of guard against that, a lot of people follow a sort of a rule of thumb, if you like, a little guideline called the rule of three, which is we wait to see three examples of duplication, because that gives us a better chance of spotting what the pattern is and introducing the right abstraction. One of the most common sources of what they call leaky abstractions, that's abstractions that don't really hold for many of the examples we use them for, is when we refactor too early. We haven't really seen what the pattern is yet. Now, the flip side of that is that we leave it too long, that we let more and more duplication build up. And the thing is that that's going to lead to a much bigger refactoring. It's going to take a lot more effort to remove that duplication. And software development is a game that involves limited time and limited resources, which means the harder something is going to be to do, the less likely it is that we'll get around to doing it. So the rule of three, and remember, it's just a guideline. It's not a hard and fast rule. It's not saying always exactly three, but on average three. Wait to see three examples before you refactor. Try not to leave it too long before you refactor, like 4 or 5 or 6 examples, because then the refactoring is going to be bigger, and the chances are you won't get around to doing it if it's too much effort. So that's the rule of three. It guards against introducing the wrong abstractions, but it also guards against leaving too much duplication in the code, so we end up not refactoring it. So we've only got two examples here, turning north to east, turning east to south. So from that and from this, I don't really see what the pattern is yet. So what I'm going to do is I'm going to keep going and introduce a third example that hopefully will make it a little clearer. So this time, I think it would make sense to west. Turning south to west here. Again, assert first and work backwards to the setup, so we end up with exactly the setup we need, and only the setup that we need. You will note also that I have got auto-completion switched off. That's another thing, if you're working backwards, that can be very, very helpful. although it can lead to your cursor bouncing all over the screen. And this time we're facing south to begin with. So we tell the rover to go right. So you can see these tests are very, very similar. So when we're done with this, we will probably refactor our code to remove this duplication. Let's run this test and see what happens. It should fail because it's still facing south. There we go. Yep, still facing south. And again, simplest thing I can do to fix this at the moment probably is to when we go say, okay, well, if it's facing east, let's make it go south and return. You might ask, why am I returning in each of these? I'm a big fan of nice flat if statements. I'm not a big fan of nested if statements. Oops. And then here. So again, we're seeing a pattern emerging here as well with these three examples. So we should end up facing west. Let's run that. So what is the pattern here? Well, first of all, we figure out which way we're currently facing. And then if we're going right, we move clockwise to the next one on the compass. So from north to east, east to south, south to west. So we're kind of going around in a circle, if you like. So how could I represent this in a simpler way? Well, let's imagine that we just have a list. So our compass is a list of directions. Let's do it like that. North, east, south, and west. So imagine we have a compass like that. Look, I'm ultra paranoid here. I'm rerunning my tests just to make sure I haven't just broken something. Okay. And now that we've got that, what we can do is we can find out which way we're currently facing in terms of the index of which way we're currently facing. Oh, we need an array, don't we? So let's pass our compass in. Okay, and again, we run the tests. Super paranoid. And all we need to do, really, is have it face the next one on. So basically add one to the current direction we're facing in. Simple as that. And then we can get rid of all these duplicates. So 3 examples of what looks like a very similar thing. And hopefully what we've got here is something that works for all of those examples. So we've introduced an abstraction here. We've introduced the idea of a compass. And that might even at some point become its own class, its own type. I don't think it's necessary for now, but again, that would be in response to seeing some duplication. Now, we've introduced a little abstraction here, and that abstraction should be able to handle our fourth case. But remember what I said about the test code. Now, there are people going around saying you should leave all of the duplication in your test code. And there is a case there that we'll talk about at the end for leaving some duplication in your test code, as indeed there is a case for leaving some duplication in your source code. But what I've found over the last 20 years is that when you leave a lot of duplication in your test code, you end up with just a mountain of test code to maintain, and it becomes a problem. So I'm not a fan of leaving duplication in the test code, but I do like when I read a test to see everything inside the test, to see the setup and the action and the assertion if at all possible. Um, so I'm looking for a simple mechanism here to essentially remove the duplication from these tests. And one way to do it would be to use what are called parameterized tests. Now, if we add some parameters to this test, just as an example, so starts facing is going to be the name of this parameter, okay, and ends facing is going to be the name of this parameter. And what we can do is we can use a different attribute that comes with the NUnit framework that allows us to specify test cases, test data values for this particular example. And they need to be in the same order and the same type as the parameters for the test. So as long as that matches, this should work fine. So that's the direction that we start facing in. And that's the direction, oops, no, completely incorrect. That's the direction that we start facing in north. We should end up facing east. So this is a parameterized version of the original test. And if I run this, it should pass exactly as before. But now you'll see that it's actually added a test case to my test results there. And what I can do very, very simply is I can now reuse this. And there's a very important word. I can reuse this. So we're going from east to south to essentially be our other tests. So our other examples are from south to west. So reusing this one test, let's just run those. And these two tests now are redundant. They're captured now as test cases for our one parameterized test. So let's get rid of them. So quite a lot less test code, as you can see, but the test hopefully is still readable. Very, very important with parameterized tests to choose parameter names that are very descriptive so that you can just read the setup for the test and it all still makes sense. Now, this test name is now a little misleading, so let's rename it something like turns right clockwise. So there's an opportunity now that we've consolidated these three tests, these three examples into a single test to capture, rather than capture examples in the names of the test, we're actually capturing the rule. We're documenting what the rule is. We turn right clockwise. And then we can see that we have three examples of turning right clockwise. So it helps us to make our tests read more like a specification than simply a list of examples. So it's a bit of a win-win there, less test code, and it reads more like a specification. It's a bit more descriptive. Now that we've done this, adding a new test is much, much easier. And that is often a clue that you were right to remove the duplication when you did, because you can now easily reuse this new abstraction that you've created, for example, this parameterized test. So we're going west back to north. So we're reusing our parameterized test. And if you think about it, the opposite of duplication is reuse. So that's a very easy way of remembering it. When we introduce reusable elements, reusable units into our code, like parameterized methods and classes and so on and so forth, we're often doing it in response to seeing some duplication, and we're discovering the need for these things by examining the duplication in the code. So it's quite an evidence-based way of coming up with a simple design. We're not sitting down thinking, oh, well, I'm going to need a parameterized test. We discover the need for a parameterized test. And because we introduced it by refactoring, after we'd seen what the pattern was, we're probably going to end up with a better abstraction. We tend to find that, for example, frameworks, reusable frameworks, are best designed by removing duplication from our code. They're best discovered, they're best not designed up front. Okay, so we've done that, we've removed some duplication, we've got now another failing test that was very, very easy to add because we've parameterized this test. Let's just check why that's failing. Okay, so we're going over the edge of our compass there. So if we're west and we add 1, then we're out of range there. Now, one way that we can handle that very easily would be to just basically go back to the beginning. So we could use modulus 4. So in other words, if the index is 3 and we add 1, then it will be going back to 0. Modulus of 4, mod 4 of 4 is 0, basically. So it loops back to the beginning of our compass there. And that should, with any luck, work. Lovely. So there's our compass, there's our abstraction, that's turning right in a circle. What about turning left? Now, we're going to finish by talking about when we might choose not to remove some duplication or when we might choose not to reuse. Now, in this case, I could add another parameter here for the direction. So let's say, what direction are we turning in? And I could say, okay, so these are all turning right. Turning right. And we'll come on IDE. Sometimes I find that IDEs will get in your way, and you have to spend a bit of time figuring out. So there's our direction. We're not using it at the moment, but let's just run our tests and make sure I haven't broken anything. And we could now use that parameter here. And that would mean that it would be very easy. Let's just tidy up our code a little bit there. It would be very, very easy to just add another test case for turning left from, say, north to west. So we're going anti-clockwise. Okay, that'd be very easy to do. There's our next failing test. But I think that this is going to be harder for people to understand. We could, theoretically, because we're going to be testing our rover through this go method with right and left and forward and back, we could test everything basically reusing this one parameterized test. And that might seem very efficient in terms of the amount of code, but it's going to be harder for people to understand, particularly when we say, well, what should this test now be called? Turns right clockwise and, bit of a clue there, and turns left anti-clockwise. Well, are we just going to keep, is that the name of this test just going to get longer and longer and longer? So my experience has been with parameterized tests, for example, that we can end up in a situation where we're reusing the same test for so many different behaviors, so many different rules, that it makes our test code very difficult to understand. And we end up in a situation where people are back to essentially reading the examples and trying to reverse engineer. Okay, so what is the rule here? So to make the test code easier to understand, I wouldn't do any of this. What I would do is I would say, well, this is a different rule, so I'm going to write another new test. Turns left, north to west. So we're triangulating again here with more examples, but this time this is a different rule, so I think it deserves its own test. So it should end up west, rover, and etc., etc. So what we end up with is essentially one test method, which may include some duplicate code, some duplicate setup, for example, but one test method per rule or per behavior so that we can read those and go, okay, it turns left clockwise, it turns right clockwise, turns left anti-clockwise, it moves forward one square, moves backward one square, etc., etc., so that we can read our tests and we don't have to kind of figure out from the examples what are the rules here. We can document the rules using the test. Now I'm going to fast forward this, so I'm going to pause recording and fast forward while I finish this off. So I've just finished off the 4 examples for turning left anti-clockwise, and you can see what I've ended up with here is 2 distinct test methods that are, yeah, very similar, but they now each document one particular rule. They have one reason to fail, if you like, or they describe one thing, one behavior with several examples. So we tend to find that this kind of test code is easier to follow. So I've deliberately chosen to leave some duplicate code in there specifically to make these tests easier to understand. So the exception when we wouldn't remove duplication is when leaving it in makes our code easier to understand. So there's 3 things we've looked at. We've looked at why removing duplication can reveal abstractions in our design. It is a good way to discover what the design really needs to be, a great way of discovering abstractions and reuse. We talked about the rule of 3, about avoiding the risk of refactoring duplicate code too early and therefore ending up with the wrong abstraction, but also avoiding refactoring or leaving the refactoring until too late, because then it's going to be a lot more effort and therefore we're less likely to actually do it. And finally, we've talked about how we might choose to leave some duplication in the code if it makes the code easier to understand. And that, of course, is always more important. So there you go. That's our 4th video. I will see you in the 5th.